In this final section, we're going to look at some various relationships between matter and energy. A few things to remember when considering these relationships. Mass and matter are always conserved. We will not consider things like an asteroid bringing new mass to the Earth. No energy conversion is 100% efficient. Some energy is always being quote-unquote lost to less useful forms. With the exception of some radioactive processes and the heat within the Earth's core, all energy on Earth ultimately comes from or came from the sun and solar radiation. While some of these cycles have parts that occur quickly, some cycles take hundreds, thousands, and even millions of years to complete. The first relationship we're going to look at is convection currents. Convection currents occur in the mantle, the ocean, and the atmosphere when fluid, either magma, water, or air, is heated and that heat rises. As it moves away from the source of the heat, it cools and then falls downward. So we have these currents of heat rising, cooling, and falling. Heat rising, cooling, and falling. These currents move heat throughout the fluid. So you can see these convection currents in the water, right? This is in your stove. This is the heat source. The heat rises, cools, and falls. Rises, cools, and falls. Same thing happens if the stove instead is the core of the Earth. We have these convection currents under the Earth. Here's another relationship, the rock cycle. Through the rock cycle, different rocks are created and weathered away. All of the matter remains the same, it just changes form over millions of years. So we have this cycle from magma to igneous to sediment rock to sedimentary rock to metamorphic rock, and then melting results again in magma. And this happens through a process of heat, pressure, weathering, erosion, compaction, various things that take the rock and over time change its form, using energy to make an impact or a change on the matter. Weathering and erosion, as you see here, here, and here, are physical changes. The pieces of sediment have not been chemically changed. They are the same molecules, but the process of metamorphism, forming a metamorphic rock, involves enough heat and pressure, here or here, involves enough heat and pressure that the rock is chemically changed and new molecules are formed. There are many elements that have their own cycle, like the nitrogen cycle shown here. In basic terms, the nitrogen cycle is just a cycle in which nitrogen, in various forms, moves through both living and non-living things. These cycles show the chemical processes that place the element in different molecules in different forms and how those molecules are used. The actual steps and details of how this nitrogen cycle takes place is not necessarily important for you to know. It's just important for you to know that this is another one of those relationships between energy being put in, energy being taken out, and the matter, in this case the nitrogen, changing forms. Here's another matter and energy relationship that you might be familiar with, where plants, so this is your plant cell, right? Plants use energy from the sun, this light energy here, to convert incoming carbon dioxide and water into glucose and oxygen. The glucose and oxygen can be used in the cell to perform some process, so requiring chemical energy, and then releasing that carbon dioxide and water, and then the cycle can continue. In terrestrial ecosystems, the primary source of energy is the sun. Producers use the energy from the sun to make food in the form of glucose. That glucose is used as a source of energy for the consumers. So the producer in this case would be this plant, the consumer here, this little rat. Molecules are cycled through the chemical processes, and energy is converted to heat through respiration. So what happens here? The light energy from the sun results in photosynthesis, and remember that photosynthesis results in a release of oxygen and an energy form. Through respiration, the consumers can take in that oxygen, use that energy for work. Some of the energy is lost as heat, and then we release what are the products of this process? Water and carbon dioxide. And then the producer can then use that released water and carbon dioxide from the respiration. So the producer, the plant, takes in the water and the carbon dioxide, takes the energy from the sun, and again, the cycle just continues. Moving up trophic levels from primary producers up to top carnivores, more energy is needed to sustain the members of the species. There will always be fewer top carnivores up here than there are primary producers down here. Remember that the sun's energy is used to power these primary producers, and then up the chain we go. Energy is converted to heat during the process of respiration. The ecosystem would collapse without the input of energy from the sun. So as we go up, remember, no process is 100% efficient. There is some energy lost. If the sun was not constantly providing an input of energy, eventually this energy lost would result in no energy remaining, and then this cycle would stop.